One of the scientific facts revealed by the new James Webb Space Telescope is the immense size of the universe. A massive object hidden in the cosmos has been discovered by a space-based observatory. What was the JWST's discovery? How massive is it? What are the implications of the size? Join us as we discuss how the JWST just discovered a massive object 100 times the size of the Milky Way galaxy, among other things. One of the broadest fields in human history is astronomy. Humans have been in awe of what we see in space for many generations. There is very little doubt that we will witness further scientific breakthroughs in space with the introduction of instruments like the mighty James Webb Space Telescope, suggesting that the telescope's rather hefty development costs of $10 billion and the complexity of the design are perfectly justified. Scientists and the general public continue to be shocked by the grandeur of objects in space. The Alcyonius galaxy, one of the largest objects ever discovered, demonstrates how nature is compelled to fill the vast span of space that exists and is potentially habitable. Its unintentional discovery, which is also true of many other life-changing discoveries or breakthroughs, adds to its fascination. Alcyonius is a radio galaxy. If you're wondering what that is, a radio galaxy is a galaxy that has a supermassive black hole at its core. As matter falls into the black hole, it generates and releases energy in the form of two radio jets from opposite sides of the galaxy's core, which is also known as an active galactic nucleus. Radio galaxies are unusual objects that originate in low-density conditions and have an estimated total linear length of at least 2.3 million light-years. Astronomers study radio galaxies to understand more about the origins and evolution of radio emissions. The researchers chose the name Alcyonius from Greek mythology since he was the son of Uranos, the primordial lord of the sky. Alcyonius was a giant that battled Heracles and other gods for control of the universe. The famous Pergamon altar in Berlin houses a sculpture of Alcyonius. A team led by PhD student Martin Oy discovered Alcyonius, the largest galaxy ever spotted. Another unexpected element of this finding is that it disproves some long-held beliefs about the formation of radio galaxies. Why is that so? Scientists had never seen such massive objects produced by a single galaxy, so the fact that the newly discovered galaxy was photographed with two plasma plumes was unusual. Nevertheless, researchers determined that some galaxies have a sphere of influence that extends far beyond their usual surroundings. How large is the Alcyonius galaxy? Remember how measurements in space, such as this galaxy, works. Scientists can only acquire cosmic images from one perspective, that of the Earth, which limits their ability to determine the length of a galaxy. Scientists typically measure a low estimate of overall length, but in the case of Alcyonius, the low estimate is still astounding. The galaxy stretches for more than 16 million light-years, which is equivalent to aligning 100 Milky Way galaxies. Over 1,000 radio galaxies have been identified by scientists, but only 10 of them are longer than 10 million light-years. Alcyonius was discovered using data from the LOFAR 2-meter sky survey, or LOT, by removing angular compact sources and imaging at 60 and 90 resolutions. The LOT DR2 was reprocessed. The images obtained enabled them to study a new sensitivity area for radio galaxy lobes, and hence provide exciting evidence for the search for unknown radio galaxies of great angular length. And in terms of cosmic distances, Alcyonius is rather close to Earth. It is just around 3 billion light-years away, which is still close to our galaxy's backyard. Astronomers say the enormous galaxy encompasses a sky region equivalent to that of the Moon. Scientists were thrilled by the Alcyonius discovery because its plumes give information about some of the most difficult filaments of the cosmic web to characterize. The cosmic web in this context refers to the present grown-up universe, which looks like a network of filaments and clusters. Observing galaxies, filaments, and clusters is not difficult. What is difficult is identifying the medium between galaxies, which has only been done a few times. Scientists anticipate that Alcyonius will change this. This is because Alcyonius inhabits a filament, and its plumes encounter a headwind as they move through the medium. This happens with the Milky Way as well, but the difference is that it gradually changes the direction and shape of the plumes. For many years, scientists assumed that the structures and pressures of radio galaxies' plumes may be influenced by filament features. However, before the discovery of Alcyonius, scientists had never uncovered an example of such a relationship. They now reveal that Alcyonius plumes are so huge and uncommon that the surrounding medium may readily shape them. So how did Alcyonius become so massive? There are some theories. The researchers that discovered Alcyonius believe it was created by a massive black hole. They discovered that Alcyonius did not stand out in the three properties stated above, despite the fact that a large number of stars with a lot of stardust have highly intense jet streams. For the time being, the genesis of Alcyonius remains a mystery. Many people are aware that planets have moons. The Earth, for example, has one, as any high school geography student will confirm. Certain planets, like as Jupiter and Neptune, have multiple moons. Asteroids with moons, on the other hand, are uncommon. Only about 150 of the approximately 1.1 million asteroids observed so far have moon companions. But scientists have discovered a much rarer asteroid with 3 moons. How did the asteroid Electra acquire not 1, not 2, but 3 moons? It's worth noting that while Electra was first identified as an asteroid in the 19th century, its role as the supreme commander of an army of 3 moons was only recently confirmed. A 160-mile-long asteroid was found in the asteroid belt between Mars and Jupiter in 1873. Its first moon was spotted in 2003, and its second moon in 2014. 130 Electra, or Electra for short, also offered scientists how to detect other faint, difficult-to-find moons, such as those linked to asteroids. Asteroids are rather small and only dimly illuminated at best. Thus anything even smaller put adjacent to an asteroid will be dimmer and fainter, since it will most likely be outshone by its parent asteroid, making moons smaller or closer to their parent difficult to detect. Exoplanets are exceedingly elusive for the same reasons that they orbit their parent stars. The first moon, which is around 6 kilometers long, orbits Electra at a distance of around 1,300 kilometers on average. The second moon, which is just 2 kilometers broad and circles the asteroid at a distance of 500 kilometers on average, is even smaller. The newest moon, with an orbital distance of around 340 kilometers, is also the smallest in the group, measuring only 1.6 kilometers in length. This makes it difficult to see. It is approximately 15,000 times fainter than the asteroid. The third moon orbiting Electra was discovered by Anthony Burdo of Thailand's National Astronomical Research Institute and his colleagues. The researchers meticulously analysed the raw data from the spherical instrument located on the European Southern Observatory's Very Large Telescope using a freshly created data reduction pipeline to carefully and successfully reduce noise. The sphere captures incredibly detailed imagery of objects in space, and it can extract images of extremely faint objects with the use of a 10-meter telescope. Surprisingly, the third moon was found in earlier photos using current processing techniques. They used data processing techniques to forecast and delete the asteroid's bright light, known as a halo. Electra's third moon surfaced after the data was processed, implying that the moon was present in the data all along, but was undetectable to the processing processes available in 2005. Several elements of Electra and her moons are still being studied by scientists. For example, they are confused how 4 objects came to be linked. One idea is how the 2-moon asteroid Cleopatra originated. Though scientists have yet to determine how frequently the process occurred in the solar system, they were able to deduce that the twin moons were most likely formed from matter expelled by the parent body. All 3 moons might have formed in the same way as Earth's moon did, implying that they were most likely formed by the collision of another asteroid on Electra. One reason scientists hunt for moons circling asteroids is to improve the accuracy of mass calculations. If an asteroid does not have a moon, Its mass can be estimated based on its size and composition, although even the process may provide erroneous results. When moons are present, astronomers can use a set of Kepler's equations to calculate an asteroid's mass. Scientists can calculate an asteroid's density based on its mass and size, which gives a wealth of information on its composition. It can tell whether an asteroid includes metal or is merely a collection of low-density rocks held together by gravity. As a result, understanding about an asteroid's moons can provide a lot of information about it. The discovery of Electra's third moon also acts as a sort of test run for a technique that may fundamentally alter how we discover celestial objects. It's crucial to remember that the moon was found by taking a fresh look at previously collected data. Therefore, many moons could still be concealed in past records, waiting to be found. All it takes is a new perspective on the data. Take time to reflect on these incredible space discoveries in the comment section below. If you enjoyed the video, please subscribe to the channel.